Okay, Chapter 2, Differentiation, Section 2.1, the derivative and the tangent line problem. Take a moment, pause the screen, and attempt the 2 warm-up problems, please. Okay, we talked briefly about this. The tangent line problem. This is what we did at the beginning of the year. Don't write this stuff down. Let's see if my computer is going to work. No notes. All right. So what is a tangent line? A tangent line is a line that intersects a function at exactly one point. Now, look at this line. If you extended it, it would intercept the function at another point, but it's still tangent to the function at the point P. So the tangent line problem is, if we only have one point on the curve, how do we find the slope of this line? So hopefully on the warm-up problem, you weren't able to do number 2. We will develop those techniques in this section. Okay, so we did talk about this again. Don't write this down. Okay, don't put it in your notes, just listen. So we said a secant line is a line that intersects a function at 2 points. What happens to the secant line as the distance between the 2 points gets infinitely smaller? So notice as we make delta x approach 0, eventually the secant line becomes the tangent line. And it's that basis that we will be able to find the equation or the slope of a tangent line. Okay, so the slope of the tangent line, and you guys wrote this down for me on day 1, but here we have secant line PQ. As point Q gets closer and closer to point P, the secant lines become the tangent line. So the slope of the tangent line is this relationship. Now I'm going to do a bunch of examples with you, but this is the notation that I had you guys do last on your first quiz throughout some homework problems, so you got re-familiarize yourself with function notation. Okay, so do put this in your notes, okay? So write this whole relationship for me. All right, so find the slope of the graph of h of x. It's the parabola 6 minus x squared at the point 1, 5. Okay, so we have 1 point on the function. This would be the point of tangency. And here's our function, so we use the limit statement. Limit as delta x approaches 0. Now this is sort of your side work. You need, in this case the function is h, you need h of x plus delta x. And this is what you were having such issues with last chapter. X plus delta x. In my function h, I'm going to replace my x's with x plus delta x. So 6 minus the quantity x plus delta x squared. You're going to become very good and very quick at expanding a binomial. Square the first term, double the product of the 2 terms, square the last term. Now the biggest issue that you guys were having is with this delta x. Treat it as any other variable. You can rename it using a variable, but I would recommend to you, if you're going to do that, replace it with the letter h only, okay? But you'll see me use delta x. CalcChat will have delta x. So the slope of the tangent line comes from h of x plus delta x. So I'm going to distribute that negative on the expansion. Then I have to subtract the original problem. So the original function is 6 minus x squared. all divided by delta x. Alright, so my last step would be distribute that negative. Alright, now look what cancels. 6 minus 6, negative x squared, positive x squared. And now look at what's in the top. We have a delta x that's common, so I'm going to factor that out of the two remaining terms. Now, these delta x's cancel each other out, and we no longer have a direct substitution of 0 over 0. So now when I substitute in the 0 for delta x, I get negative 2x. I want the slope at the point 1, 5. So if I evaluate this at the point 1, 5, my slope is equal to negative 2. And for the beginning, the first several sections will only look at replacing one variable, the x variable. We will talk about the difference between when we have to use both the x and y coordinate, but not yet. Okay, so differentiation, that's the whole basis of the chapter 2. The differentiation is just it's being able to find the derivative of a function. So differentiation is the process of finding a derivative. What is the derivative of a function at x? This is the notation for it. F prime of x, that's how it's read. And what's the derivative? It is this limit, this entire limit put together. So the limit as delta x approaches 0, f of x plus delta x minus the original function divided by delta x. And look at what it is. What's the derivative equal to? The slope of the tangent line. And we will continue to go over that and over that again. Okay, I think it skipped a slide. Let me go back. Okay. Find the derivative of f of x equals negative 10x. So the derivative, f prime of x, is the limit as delta x approaches 0. Remember, your side work, what you'll have the biggest issue with is this relationship. So in my function f, wherever I see an x, I'm going to replace it with x plus delta x. So f of x plus delta x. Then you have to subtract the original function. The original function is the line, negative 10x. And the reason we have to subtract the original and you'll begin to notice this more, any term that doesn't have a delta x is going to cancel. So now on this final step I can have, we will see that the delta x's cancel and my limit is just simply negative 10. So what's the derivative of this function? Negative 10. What does it mean graphically? So negative 10x, that's a line through the origin with a slope of negative 10. Well, look at this. If I plotted any one point on this line, what's a tangent line? It's a line that intersects a function at one given point. What's the slope of every single line that I would draw tangent to this function? The slope is negative 10. Okay, so different derivative notations. We would say the derivative of f with respect to x f prime of x. That's the one that we'll use most frequently. The next one, dy dx. The third one, y prime. We know in function notation f of x is equal to y. So f prime of x must be equal to y prime. The derivative with respect to x of a given function. And this is noted in the book, but I've never seen this used before. And here we go again. What's the derivative? It's the slope of the tangent line. So if we think about the first slide, how do we find the slope of a tangent line? If we only know one point, we find the derivative of the function. The issue for you guys right now is that to find the derivative, it's an intense limit definition. Okay, so our little side work, x plus delta x. Wherever I see an x in the original function, I'm going to replace that with x plus delta x. So it's certainly algebra intensive. Square the first, double the product, square the last term. Distribute the 3, delta x plus 4. And now remember, we subtract the original function. So it's really the opposite of all of the terms in the original function. So I'm going to put both of these pieces together. X squared plus 2x delta x plus delta x squared plus 3x plus 3 delta x plus 4. Subtract the original. I'm just distributing the negative. Now everything that doesn't have a delta x should cancel. X squared minus x squared. 3x minus 3x. 4 minus 4. After those non-delta x terms cancel, I'm able to factor a delta x out of the remaining terms. So 2x plus delta x plus 3. This gets my 0 over 0 to cancel. And now I can make the direct substitution of 0 for delta x. So my derivative, f prime of x, equals 2x plus 3. So what does this mean? I'm sorry, this is so slow. So the slope of any line tangent to the function slope of any line tangent to the function is this line. Okay, we'll stop there for now.